Okay, so we know that we have a circular saw that's rotating at an angular acceleration of 14 radians per second squared, and it reaches a max velocity of 15,000 revolutions per minute. Now, the first thing we want to do is solve for the max speed, and we see that the max speed is in revolutions per minute, so we know that what we're looking for is the max speed in radians per second. So the first thing we're going to do is convert this 1500 revolutions per minute to revolutions per second. You're just going to do that by multiplying 1 minute over 60 seconds will give us 250 revolutions per second. Now we know that every time it rotates once is 1 revolution. We know that in radians is 2 pi, so let's just convert it to radians. We end up with 250 revolutions per second times 2 pi radians per 1 revolution. And you see these revolutions cancel out, and you end up with radians per second, which equals 500 pi radians per second, which equals 1570 radians per second. Now, how long does it actually take to reach this max speed? We know that the final angular velocity equals the initial angular velocity plus acceleration times time. Now we have everything we're looking for to find the time. So let's just algebraically solve this for time. We end up with angular final velocity minus the initial angular velocity over acceleration. And just plug in the numbers in, we end up with 1570 radians per second minus the initial, which we know that it starts at 0 radians per second squared, so minus 0, over the acceleration, which is 14 radians per second squared. And we end up with 112 seconds to reach the max speed. Now, we're trying to look for how many rotations it actually takes to reach this max speed. So what we're going to do is we know the kinematic equation for the distance is going to be the change in the angles equals, which the change in the angle is just the how many times are rotated, equals the initial velocity times time plus 1/2 a times time squared. Now let's go ahead and plug our numbers in, and we end up with the initial velocity of 0 times time, which is going to equal 0, plus 1/2 times this 14 radians per second squared times 112 seconds, which is the time squared. Now what we end up with is 87,800 radians. Now, this is not exactly what we're looking for because we're looking for the revolutions, not the radians. So all we're going to do is we know that each revolution is 2 pi radians. So we're just going to go ahead and divide. We're going to take this 87,800 radians times 1 revolution over 2 pi radians. These radians cancel out, and you end up with 1,400 revolutions. And this is how long it takes to reach that max speed.